so before we do the derivatives of inverse trig functions, I really want to review what inverse trig is. So turn over to the very back page of your packet where it's completely blank, the very last page. And I want to review inverse trig. So the first thing is regular trig. What is sine of pi over 6? So pi over 6 is 30 degrees. So what sine is 30 degrees? Like if we were to draw a triangle, there's 30 here. That would be 1 root 3 and 2. So that would be 1 over 2. Opposite over hypotenuse, right? So this is just regular trig. So inverse trig means we're using the inverse function. So there's a couple of ways. Well, 2 would be the reciprocal, and that would be what cosecant is. But by inverse, I mean this. Or another way to write this would be to say arcsine. Now, this is really how we're going to write it. We're not going to use the -1 notation in calculus. The only reason we really even use this a whole lot in pre-cal is because that's how your calculator has it. All right? It's way too easy to get arcsine and sine mixed up. But when it's spelled out like this, it's not as easy to get them mixed up. So I want you to see what's happening. Instead of me giving you the angle and me asking you for the ratio, I'm giving you the ratio and I'm asking you for the angle. So just approaching it the same way as we did this one, what you would do is you could draw a triangle and you'd mark theta. And what we're going to do is we're going to try to find theta. You're still going to use opposite over hypotenuse, so opposite over hypotenuse. You could do Pythagorean theorem if you wanted to find the third side, although you're going to quickly remember the whole 1 root 3, 2, and the 1 root 2 and all that. And then you just say, okay, that's opposite the short side, the short leg, so is it 30 or 60?
30.
30, which is the same as pi over 6. Okay, so up here in the red, this is just solving a trig exact value. What I've done here is inverse trig. I've given you the ratio and I've asked you for the angle. Okay, let's do another one. So let's say we're doing arc cosine of 1/2. Okay, so again, what I'm asking you is, what is the angle that when you take cosine of that angle, you get 1/2? The better you were at trig exact values, the easier this is going to be. Now, if you're like, I don't know what that is, go draw a triangle, draw your theta, and then in cosine, what would the ratio be? Adjacent over hypotenuse. So the adjacent would be the 1, the hypotenuse would be the 2, and again, that third side would be root 3. All right, you could use Pythagorean theorem if you don't believe me, but we know these are the ratios that pop up. And so since theta here is across from root 3, is it the 30 or the 60? Yeah, it's the 60, which we're always going to use radians. Okay, so we're going to practice this a few more times, but are there any questions so far?
Just a quick review, why do the root 3 and 1 switching in for the triangles?
Well, okay, remember that up here, sine, I did opposite over hypotenuse. And here I did adjacent over hypotenuse.
Well, I meant like for the triangles, like why is
I know, yeah. So you start with theta. So up here, the 1 is opposite the theta. Down here, the 1 is the adjacent to the theta.
Okay, I see.
So before you started with the 1 root 3, 2, then you found the angle. Here, I'm marking the angle. That's the very first thing I did when I drew the triangle. Then I labeled the sides.
Right.
Then you identify the angle. Okay. So let's try one more kind of like these. All right, so arc sine of root 2 over 2. Again, what I'm really asking you is sine of what angle is root 2 over 2, which you may know just from memory. The better you know trig, the easier this is going to be. Okay, if you don't know trig, you draw a right triangle, and Brett, this is what you were asking. I mark theta, then I do opposite over hypotenuse. Since it's sine, I go opposite over hypotenuse. Now, if you were to do Pythagorean theorem here, you would get root 2 down here. Now, we're not used to seeing it necessarily like this. Usually, on these isosceles triangles, you see it like this, 1, 1, root 2. Although I'll tell you, root 2, as long as these two sides are the same, this angle is always what? Pi over 4, 45 degrees. Okay, so before I move on, let me just test you out just a little bit. What would arc cosine of root 2 over 2 be? The same. Why?
Sides are useful.
Yeah, the sides in this case opposite, adjacent, it doesn't matter which one's which. Do you have a question? Does it have to do with radians and degrees?
Yes.
Okay, I'll go over that. So pi over 6 is 30 degrees, pi over 3 is 60 degrees, and pi over 4 is 45 degrees. I would just know this, it's worth it, we use it enough, but if you, the way we did this in trig was you multiplied by 180 over pi, or pi over 180. That was the conversion rate. Because basically it's like a proportion, you know, out of 360 or out of 2 pi. But if you just know this, that's going to make your life easier. What would 90 degrees be, by the way? Pi over 2. And pi, then, is 180 degrees. 2 pi is 360. 3 pi over 2 is 270. If you still have your unit circle from last year, all of this is on there as well. That would be a good study tool. Okay, so let's try, let's change it up just a little bit. All right, let's try an arctan. So arctan of root 3. So again, I'm not asking you just to know this, although some of you might. You might have had these trig values memorized still from last year. But for everybody else, draw the triangle, mark your theta. What's the ratio for tan?
Opposite over adjacent.
Opposite over adjacent. Now, if it's not over anything, just put it over 1. So that's going to make the square root of 3 go opposite, and adjacent to theta would be 1. That would make the hypotenuse 2. And then theta, since theta is across from root 3, that's the 60-degree angle. My answer is pi over 3. Like anything else, this gets easier with practice, and then when you don't look at it for several months, it's, you know, it's kind of hard to remember. So it'll come back to you. You can also check any of these on the calculator. I really want to encourage you to try to use the calculator sparingly, but while you're learning, if you're not sure, just check it, type it in. All right, let's try another one. This one, some of you I think will get right away. If you know it, shout it out. Pi over 4, very good. How'd you get that so fast? Yeah, if the ratio is 1, then the adjacent and the hypotenuse have to be the same. That's a 45, 45, 90 triangle. All right, so far I've only done 30, 60, and 45. But we know we have all those quadrantal angles. So like, for instance, if you were to see arc sine of 1, well, you can't draw a triangle for this one. What would happen if you tried to draw a triangle for this? Yeah, the leg and the hypotenuse would both be 1. That can't happen. Your hypotenuse has to be the biggest one. Okay, so some of you, again, you know this. Some of you know OIO chart. Some of you know another way to do quadrantal angles. The way I've kind of encouraged this year is to know the parent function. So this right here is the parent function for sine. So remember, it goes up to 1, down to -1. So in the first cycle, what I want to know is, when does sine reach all the way up to 1? What's this angle right here?
Pi over 2.
Pi over 2, because it's broken up into 4. We know that pi over 2 is the cycle, is the period, and so pi over 2 would be this quarter of it right here. What if I was doing arc sine of -1? What would the answer be then? 270. Could you say negative pi over 2? Okay, so this actually gets into this idea of restricted range, which is not going to be nearly as big a deal as you think, so I'm not going to talk any more about it because that gets too detailed oriented. But I want you to see there's actually infinitely many solutions for all of these. So I would just stick to the most simplest answer. Okay. Yeah, you can use the IOU chart. Yeah. Any way you want to do it. Okay, so let's try our cosine of -1. Whether you use the OIO chart or if you want to draw the parent function. Remember, cosine starts at a peak, so peak to peak is 2 pi. So you're looking for where does cosine dip down to -1? What is that angle?
3 pi over 2.
Be careful here, because when you break this up, you go peak, midpoint, low, midpoint, peak. So just be careful. It's just pi.
Okay.
So you pick out a way that works for you. For some people, the graph is confusing. They get off by 1 a lot. I don't care how you do it. You do whatever works for you. All right. One last one. What's arc cosine of 2? Yeah, why didn't it exist? Yeah, the range here is -1 to 1. So arc sine and arc cosine, you can only take those of numbers between -1 and 1. All right, so that's going to be interesting, and I'll come back to that. All right. What about tangent? Can you take arctangent of any number? And let's go ahead just to be thorough. We might need this later. Let's go ahead and draw the parent function of tangent. Here the range was only -1 to 1. So in inverse trig, the domain is -1 to 1. What about tangent and arctangent? Is there any restriction? Okay, so here the domain, but what I'm asking is, can I take arctan? Is there a restriction on what I can take arctan of? No, no restriction. You can take arctan of anything you want. Doesn't matter what it is. That's because the range covers all the points here. Remember, with inverse, domain and range switch. Where is this asymptote at for tangent, by the way? Pi over 2. This is -pi over 2. I'm covering a little bit more than I need because it's a good time to talk about trig. A lot of what you need for trig is found in these 3 graphs and then in the 30, 60, 90, and 45, 45, 90 triangle in SOHCAHTOA. If you know those really well, then you can pretty much figure anything else out that you want. Okay, so let's go ahead and go back to this page. And the better you know what I was just talking about, the easier this is going to be. Because this right here isn't too bad, but sometimes you're going to have to be able to solve certain things, and it's good if you know. But I also just wanted to kind of remind you what this whole arc thing meant. So if the arc was not there, okay, and it was just sine, what's the derivative of sine? Cosine, right? And if we're taking sine of something complicated, we just do cosine of that times the derivative, right? So this is different. It's a completely different formula. And you may be looking at these 6 formulas thinking, I'm never going to remember that on top of all the stuff that I really haven't remembered already, all right? Hopefully you know everything I've taught you, all right? But I know that there's holes, and everybody, there's things they struggle with remembering. So this is why I made you flashcards. And remember, we're going to have a quiz on Thursday, and you get to use your flashcards on the quiz. So you're going to start to appreciate why I'm letting you do that. Now, by the test next week, you're going to have to know this stuff. But that gives you some time. I do want to point out a couple of things. Look at the formula for arc sine and look at the formula for arc cosine. The only thing that changed was a negative. So if you know the formula for arc sine, all you got to do is put on a negative when you do the cosine. Have we seen this before with derivatives where we use a negative with the co? Yeah, that's exactly how we memorized the first 6 trig. All right, look at tangent and cotangent. U prime, and I'll get to what this means, but it's the same formula, but you just use a negative. So from tangent to cotangent, you do a negative. Okay, secant to cosecant, same exact formula, just with a negative.
So really you only have to memorize 3.
You really only have to memorize 3 and then one relationship. That is correct. That's how I would suggest you do it. That's how I remember them. Okay, the other thing I want you to write up here is these two. Remember we just said this, arc sine and arc cosine. You can't just take arc sine and arc cosine of anything, right? What are the two numbers we have to be between? Yeah, -1 and 1. And these could be brackets, actually, because you can do quadrantal angles. And if we're talking about reciprocals, I haven't mentioned these yet, but these are reciprocals. So these right here, you can only do arc cosecant and arc secant of all the other numbers. So basically like this. This isn't going to mean much to you. You're not even going to use this a whole lot, but I want to go ahead and get this out there now because it is going to come up some of the time. Very rare, but it will. All right, what about arctan and arccotan? Are there any restrictions?
Oh, no.
I'm not asking what can I take tan of. Okay, we know we can't take tan of pi over 2. There's an asymptote. What I'm asking is, what can I take arctan of or arccotan? Are there any restrictions?
All real numbers.
All real numbers. Okay, I'll come back to this and we'll talk more about this tomorrow when we look at the homework. Okay, so looking at problem 2, which is kind of weird that it just goes to 2. But anyway, we have this y equals arc sine 2x. And I realize there's a lot of u's up here. We're not really doing u substitution the way we do it with integration. We're not going to say u equals this, du equals this. Okay, we're not going to do that. All we're going to do is we're going to say, okay, the formula says that I put the derivative of the inside part, that goes on top. Have we done this before, where the derivative of the inside part goes on the top of a fraction?
Probably you.
Yeah, when did we use that? Natural log. So we've already used a rule, natural log. The only thing is the denominator is a little bit different. And notice all of these have u prime on top. It just means the derivative of the inside part that goes on top. And then for the cos, a negative. All right, so what would go on the top of this fraction on this problem?
2.
2. Derivative of 2x is 2. Okay, so then we put the square root, and we just follow this formula. 1 minus, and then I'm going to put 2x in parentheses. All right, now this is my answer, and it's a fine answer, and you do not have to simplify. But if this was multiple choice, the answer choices would be simplified. And I want to go ahead and take today, because the lesson really isn't that long. I want to take today to focus on simplifying, because some of you, you're getting multiple choice wrong, because you don't know how to pick out the right answer from your unsimplified answer. So this one's not too bad. Really, there's only one thing to do, and that is to go ahead and square the 2 in the end. So that would be 4x squared. Now you may think, surely you can do something else, but you can't. There's nothing else to be done in this problem. This minus right here prevents you from doing anything else.
Could you just change the radical to 1/2?
You could rewrite it, but the answer choice would look like this,
Okay.
not with the 1/2. But if we were doing second derivative, that might be something you wanted to do. Okay, so now let's look at, before I move on to B, how would my answer change if this was arc cosine 2x? There'd just be a negative in front. So if you can do arc sine, you can do arc cosine. All right, so now let's do arctangent. Okay, so this is this formula down here at the bottom left. So we have y prime equals, again, the derivative of 3x goes on the top, And for arctan, there's no square root, it's just 1, in this case, plus u squared. So 1 plus 3x squared. And the only real way to simplify this one would be to go ahead and square the 3 and the x. Okay, you cannot simplify the 3 and the 9. There's no other simplification to be done. And how would my answer change if this was arctangent 3x? A negative in front. That's the only way. Any questions so far? So if you know the formula, this is actually pretty easy. You just got to know the formulas. So I would maybe, like tonight, just see if you can try to memorize arc sine. And then tomorrow night, try to memorize arctan. But like I said, you don't even have to have them memorized by Thursday. I'm going to give you a whole week plus to do that. Okay, so let's look at part C. Y prime, same formula as before. The derivative of square root of x goes on the top. What would that be?
X negative 1.
1/2 x.
So it may help you to do this. Yeah, 1/2 x to the negative 1/2. And then in the denominator, the square root of 1 minus, and then we have square root of x squared, yeah, which is just x. Okay, I wanted to go ahead and deal with the rest of this as well. All right? Never in multiple choice, or rarely in multiple choice, are you going to have fractions within fractions. What they're going to do instead is take this 1/2, put the 1 up top, and the 2 down here. Okay, that 1/2 in the top is same as 1 on the top, 2 in the denominator. Okay, also, x to the negative 1/2, that's a square root of x, but where? Down here. And then the only other thing that I would say is probably their answer would just have 1 square root instead of 2, and we're multiplying, and it would be something like this, x and 1 minus x. So again, my goal here isn't that you can come up and do this every single time, but that you can pick out the right multiple choice answer. I still don't want you to simplify unless you know you're doing it right. But I want to make sure I'm at least spending a little bit of class time talking about this. Okay, so let's do the...
Would you give the fraction with it, like the 1/2?
If you had this,
Yeah.
it's right. There's no problem. And again, the only reason I'm really making a big deal about this is if there's a multiple choice, you're going to have to pick the simplified one. That's the only way the answers are going to come. So don't simplify unless you have to. Okay, so part D, we're going to have to use the secant formula. So if I look up here, it's very similar. I do have an absolute value thing going on. All right, but let's just do one thing at a time. What's the derivative of e to the 2x? Yeah. Yeah, y'all are both right. E to the 2x times 2, and we could definitely put the 2 in front, and I will do that here in just a second. All right, in the denominator, you're going to have absolute value of 2x, and then it's u squared. So e to the 2x being squared minus 1. All right, now, again, this is totally right. You should just leave your answer like this. But if it's multiple choice, you have to pick out the right answer, and there's a lot of simplification that can actually happen here. Okay, first of all, you cannot just cancel these two just because one's on top and one's on bottom. That absolute value bar, that matters, all right? However, if you can say for sure that these absolute value bars actually don't matter in this problem, then you can cancel. So my question is e to the 2x, can we say that that's always positive? Because if that's the case, if e to the 2x is always positive, then these absolute value bars actually don't matter. I want you to understand this. I can say it in this problem, but I cannot say it all the time. You can't just ignore them. I am on this one because e to the 2x is always positive. Because it's a positive number being taken to some other power. It may get really small, but it's always going to be positive. Alright, and then the only other thing really to do on this one would be to simplify this term. So what do you do when you have a power to another power?
Add them.
Multiply them.
Multiply them. So that would be e to the 4x minus 1. And here's what the answer choice, the correct answer choice would look like. Okay? Alright, before I do 3, I want you to notice on your homework, if you just turn the page really quick, they get a little bit more complicated. I've only practiced taking derivative of arc, sine, tangent, whatever in isolation. But like, so 1, I think you guys are okay with, but like, what are you going to have to do on 2?
Separate it.
Either product rule or quotient rule. One of the two. If it, as it is right here, you'd have to use quotient rule. You could make it like this and use product rule. Alright? Down here, you're going to have to use product rule and then just do what we know about taking derivatives and square root terms. You said, I mean, the ones on the homework are a little bit harder, but you can do them. Alright? The only new thing is what I just covered. Okay, so let's look at then the very last problem. So we have product rule, we have quotient rule, and then 3 actually is going to utilize chain rule. How do I know I need to use chain rule on 3? Yeah, I have 2 functions going on, the whole thing squared. So I know if I'm going to do increasing and decreasing, I've got to find the derivative. Which is the shell of this M&M? The 2, the squared. So I got to do that first, which means you keep the chocolate, the inner function the same. And there'd be a 1 here. You can write it or you don't have to. And then you would multiply by the derivative of the chocolate. So what is the derivative of arctan? This is the new stuff. Yeah. 1 over 1 plus x squared. We're just using the formula. You could put this, you could say 2 arctan all over 1 plus x squared. You could if you wanted to do that. Alright, I'm not going to do that because it's not necessary. Alright, and I need to know what my critical points are. So remember, critical points over your first derivative is either undefined or equal to 0. So undefined is the one we skip a lot, so I'm going to do this one first. So let's just go at this piece by piece. 2, okay, that's defined. What about arctan of x? Are there any x's I cannot plug in here? No, we just said that. If this had been arc sine, you'd have to do some work here. Okay? I'm not going to go into that because that's not on this problem, but that's just a heads up. Alright, so arctan x always defined. What could possibly happen in this fraction that would cause it undefined? 0 on the bottom. So we go 1 plus x squared equals 0. And then when I try to solve for x, like if I subtract 1 and I square root, I get imaginary numbers. So the good thing is, whenever you get imaginary numbers, you just stop and you say, I pretend I didn't see that. We don't have to do it, okay, because it doesn't show up on the graph, imaginary number stuff. All right, so now we want to see where is the derivative equal to 0. So this would be like the 2, the arctan x, and then the numerator here. So the 2 and the 1, I don't really care about that. So really what I'm saying is, when does arctan x equal 0? Okay, I am not asking you to find arctan of 0. I am asking you, when does arctan equal 0? In other words, what is arctan? What do you think happens when you do arc?
It's just tan.
Yeah, they cancel out. So really what you're doing here is just regular old tan of 0, which is 0, by the way. So if you hadn't made that mistake, you could have been okay on this one. It wouldn't work all the time. And again, if you're like, well, how do they know that? Think about the parent function of tangent. All right, tangent of 0 is 0. Okay, so this is my only critical point. It is possible to have more, and if we had whole areas where the graph is undefined, it would be like natural log, where we just like block off those parts of the graph. Okay, that's not what's happening here. We only have one critical point, and everywhere else is good. Okay, so now what we need to do is we need to plug in a negative number, and any negative number will do. All right, and so I'm thinking maybe -1. And I need to find y prime with -1. So I have 2. And what I need to decide now is arctan of -1. Is that supposed to be negative or positive?
Negative.
Why do you say that? The parent function, when the x values were negative, the y values were negative, and same thing, they were both positive at the same time. And again, this is something that you're not used to, but the next time you're going to know this. Arctan of a negative is a negative. Arctan of a positive is a positive. All right, so then we got to think, okay, well, what about this next term? Is this negative, therefore making the whole thing positive, or is this positive? I plug in a negative number in for x. Well, this chunk results in a negative or positive number. Positive. So the final result then is negative, right?
Yeah.
So negative means y is going to be decreasing in that whole half of the graph. Okay, now we need to plug in a number over here to the right of 0. Take any number you want. Okay, we already said arctan of a positive is positive. And really, when you look at this, you should know it's always positive. Right? And we know that it's likely that the sign is going to change here. Okay, so before we write our answer, what's going on at x equals 0? Yeah, so what do we call that? A min. There's a min at x equals 0. Okay, so now we're ready to write our answer. I didn't mean to write that, not f. In this case, y is increasing on, and we look up here, we say, oh, 0 to infinity. And we always write a reason, because y prime is positive. Then we're going to write a similar statement about decreasing. Y is decreasing on negative infinity to 0 because y prime is negative. And we're not going to do the concave up and concave down today. The second derivative on this gets messy, and you're not going to have to do it in your homework, so we'll just cross that bridge later. In theory, you should know how to do it. It's just, this is good. Okay, so again, just look at your homework really quick. You're going to have to use your tools, everything you know, product rule, chain rule, all that. All right, 5 and 6, I didn't do a tangent one. So just, what are the 3 pieces of information we need to write a tangent line?
X, Y, and slope.
Yeah, we need x, we need y, and we need slope. The y value you can get just by plugging the 1/2 in. All right, we've done this tangent line thing a whole lot. You're getting really good at it. So this is where, like at the beginning of class, when we were doing arc sine of half, this is where you're going to have to know how to do that. Okay, what do you need to do to find slope? Take the derivative, then plug in the x value. Okay, so the derivative is the new part of that. And then on this page, you have a couple more. At least though on these, they give you x and y. So all you got to do is find the slope. And then 9 and 10 are kind of like what we just did, although there is an arc sine. Just want you to try them. I don't expect you to have all of this done by tomorrow, but if you don't look at any of this between now and tomorrow's class, you're going to start getting really overwhelmed when I bring in integrals. So it's to your own advantage to try to make sure you understand at least part of the derivatives, like the main idea, so that when I bring in integrals, it's easier to separate them in your mind. Okay? Then Wednesday we have a review, and Thursday we have the quiz.